Hello everyone and welcome. Today we are diving into the world of database compliance standards. It is important to understand how to meet regulatory requirements in database management. We will be covering the General Data Protection Regulation, often called GDPR, the Health Insurance Portability and Accountability Act, known as HIPAA, the Payment Card Industry Data Security Standard, or PCI DSS, and the Sarbanes-Oxley Act referred to as SOX. Let's discuss why database compliance matters. From a business perspective, compliance helps you avoid hefty fines and legal penalties. It allows you to maintain customer trust and loyalty, which is crucial for long-term success. Compliance also protects your company's reputation and brand value, which can be severely damaged by data breaches or violations. By being compliant, you prevent business disruption and gain a competitive advantage through strong data governance. On the technical side, compliance involves implementing proper data encryption, both when data is at rest and when it's being transferred. Establishing strict access controls and authentication protocols is essential to ensure only authorized personnel can access sensitive data. Maintaining comprehensive audit trails of all database activities helps track who accessed what and when. Creating well-defined processes for data retention and deletion ensures you're not keeping data longer than necessary. And finally, developing incident response procedures is vital to effectively handle any data breaches that may occur. Now let's focus on GDPR, the General Data Protection Regulation, the European Union's law on data protection and privacy. One key aspect of GDPR is the right to access, which means users can request a copy of their personal data. Another important right is the right to be forgotten, allowing users to request the deletion of their data. GDPR also emphasizes data portability, enabling users to export their data in a machine-readable format. Privacy by design means security must be built into the database architecture from the start. In case of a data breach, you must report it within 72 hours. Failure to comply with GDPR can result in penalties of up to 4% of your global revenue or 20 million euros, whichever is higher. Next, let's explore HIPAA, the Health Insurance Portability and Accountability Act, which is crucial for healthcare databases in the United States. HIPAA primarily focuses on protecting protected health information, or PHI. You need to establish role-based access controls to ensure only authorized personnel can access patient data. Audit trails are necessary to log all database access and changes. Encryption is a key technical requirement for all PHI data, whether it's stored or being transmitted. Here's an example of HIPAA-compliant audit logging in SQL structured query language. This code creates a trigger that logs every update to patient records, including the user, action, table name, record ID, and timestamp. Now let's explore the Payment Card Industry Data Security Standard, or PCI DSS, essential for protecting payment card data. This standard requires a secure network, including firewalls and network segmentation, to isolate cardholder data from other systems. Encryption is also crucial. Strong cryptography must be used to protect cardholder data both at rest and during transmission. Monitoring is another key component, requiring you to track all access to the network and data. Regular testing of security systems and processes is also mandatory. This diagram illustrates how tokenization and authentication help secure payment data. Payment data is tokenized before being stored in a database, and authentication is required before accessing audit logs. Now let's talk about implementing database compliance, starting with data encryption. Transparent data encryption, or TDE, is used for data at rest, meaning when it's stored on the server. SSL or TLS, which stands for Secure Sockets Layer and Transport Layer Security, are used for data in transit, ensuring it's encrypted while being transferred. You can also use column-level encryption for particularly sensitive fields. Here's an example of how to enable TDE in SQL Server. This code creates a certificate, then a database encryption key, and finally alters the database to enable encryption. Audit and monitoring are also critical components of database compliance. This includes comprehensive logging of all database activities, allowing you to track who accessed what and when. Real-time monitoring can help detect suspicious access patterns as they occur. Ensure you have clear retention policies for audit logs, specifying how long these logs should be stored. Here's an example of how to set up PostgreSQL audit logging. This code creates an extension called PG Audit and then alters the system settings to log various database activities. Let's discuss access control and data governance. Role-based access control, or RBAC, ensures that users have the least privilege necessary to perform their job functions. Multi-factor authentication adds an extra layer of security for sensitive data access. Also, implement session timeouts and automatic disconnection to prevent unauthorized access. Here's an example of how to implement role-based access control in MySQL. This code creates two roles, data analyst and data admin, and then grants different privileges to each role. Data governance is also crucial. Classify data based on sensitivity levels to apply appropriate security measures. Establish data retention policies with automated purging to ensure data is not kept longer than necessary. Implement data lineage tracking to understand the origin and movement of data for compliance reporting. Here's an example of a data retention policy in PostgreSQL. This code creates an extension called pgpartment, then creates a parent table for user data, and finally sets a retention policy to drop partitions older than 24 months. To ensure ongoing database compliance, it is important to document database architecture, security controls, and compliance measures. Regular internal and external audits should be scheduled to verify compliance. Staff training is also necessary. Provide ongoing education for database administrators and developers on compliance requirements. Implement regular database vulnerability assessments and penetration testing to identify and address potential weaknesses. Ensure mobile access to databases follows the same compliance standards as desktop access. Also, verify cloud database providers meet or exceed your compliance requirements. By following these best practices, you can maintain a strong security posture and meet regulatory obligations. In summary, remember that encryption is fundamental to all compliance standards, safeguarding data at rest and in transit. Audit trails provide evidence of compliance by logging all database activities. Access controls enforce the principle of least privilege, ensuring only authorized personnel can access sensitive data. Regular testing ensures ongoing compliance by identifying and addressing vulnerabilities. Database compliance is not a one-time project, but an ongoing commitment to protecting sensitive data and maintaining stakeholder trust. For further information, you can refer to the General Data Protection Regulation, official documentation, the Health Insurance Portability and Accountability Act, Compliance Guide, and the Payment Card Industry Data Security Standard. Thank you for joining this session on database compliance standards. Ensuring adherence to these regulations is vital for maintaining data security, protecting stakeholder trust, and avoiding legal and financial repercussions. Upholding compliance is a continuous process. Stay vigilant, stay informed, and prioritize data protection in all your database activities. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.